Hello, and welcome to another chemistry topic together as we continue to learn more about the mole and limiting reactants and stoichiometry and all those kinds of things wrapped together in today's topic called percent yield. Go ahead and set up your focus note page. Our essential question is, what is the percent yield of a chemical reaction using lab data? So, percent yield is something where you are looking at what you thought was going to happen compared to what actually happened. So that's why you'll always need lab data or given lab data in order to calculate something called percent yield. So finish up setting up your focus notes, and when you're ready, continue the video. All right, so last time we talked about this thing called limiting reactant. In those limiting reactant problems, we were getting theoretical answers, meaning that in theory, like if everything was perfect when predicting the amount of product. But real talk, we know that no lab ever goes perfectly. Even if we get very good results or expected results, there's never going to be a perfect lab situation. So that's where today's topic comes in. It's thinking about, well, it's not perfect, but how close to perfect is it? That's kind of that's what percent yield topic is kind of thinking about. So first we need to think about these two terms, theoretical versus actual. An LR stoich problem determines the theoretical amount that should be produced in a reaction. Now, of course, you could do any version of a stoich problem, but when we're talking about LRs, we're almost always focusing on how much product, but it's a theoretical answer. It's just based on math. You did it on paper. It's a hypothesis. In lab, that's where you would determine the actual amount of product. So you did real data, you measured it with equipment, with a piece of chemistry equipment, something like that. So you actually got an answer compared to what you hypothesized or thought the answer would be. So theoretical is based on math or paper or perfect chemistry. Actual means you have to really do something. You really measured it, you really got an answer. Go ahead and do a level 1 question so far. Just kind of think about the stuff we talked about. Maybe this idea of theoretical versus actual, or what LR was, anything from your notes so far, just kind of straightforward kind of question. Pause the video if you need to. Come on back when you're ready. All right, so with all that in mind, theoretical versus actual, and LR is really just like what perfectly should happen. Let's imagine we had a reaction like this. This maybe looks familiar. We talked about it when we learned about LR. POCl3 plus 3 water produces phosphoric acid and 3 moles of hydrochloric acid. So here's what I might ask you. How many grams of HCl are theoretically produced from 75 grams of water mixed with 75 grams of POCl3? Okay, so we recognize, wait a second, this is an LR problem because I have two givens. And if I'm trying to figure out how much HCl can be made, I got to figure out which one of these runs out first, stops the reaction. So this is an LR problem. We're going to do this together. First, we'll figure out LR, and then we will figure out this answer, how many grams of HCl, and then I will put in the new topic for today. So the nice thing is we got some natural review built into today's new topic. So let's do this. Here's the balanced equation, here's my two givens, and then here's the question. How many grams of HCl? All right, so I got to figure out which one of these runs out first. So I'm going to do two stoich problems. For each stoich problem, I'm going to convert to HCl. So I'm going to go from POCl3 to HCl, and then also water to HCl, and then answer this question. How many grams of HCl? So one of my givens was 75 grams of POCl3. To get to HCl, I need to be able to do the mole switchover step from the balanced equation, which means I need to get the molar mass of POCl3 so I can get 2 moles of POCl3. So I add it up. P is 30.97, O is 16, Cl3, 35.45. Add it all up. This is the molar mass of this compound so that I can go from grams to moles. Review. If grams is on the top here, it needs to be on the bottom here. So I set that up. Grams will cancel, and now I'm at moles of POCl3. Now I can do the switchover step. So I need moles of POCl3 to cancel. So I'm going to put the 1 mole of POCl3 from the balanced equation on the bottom, switch over to 3 moles of HCl on top. Moles of POCl3 will cancel. I'm at moles of HCl, but the problem was asking for grams of HCl. So once again, I get out my periodic table and I find H and Cl. H is 1.01, Cl 35.45, 36.46 grams per mole. So when I set up my problem, I need moles of HCl to cancel. It's on the top here, so it goes on the bottom here. 1 mole of HCl for every 36.46 grams of HCl. Moles of HCl cancels. I'm at grams of HCl. That is what the problem is asking for. So I'm ready for calculator. Go ahead and pause the video if you need to catch up on any of this. But now I'm going to multiply every number on the top, divide every number on the bottom, and I get this math answer. And then I look at sig figs. This has 3, this has 5, this has 4. None of these are measured numbers, so there's no sig fig errors with them. So I can keep 3 sig figs. 1, 2, 3. I look at this number for rounding, which it does not. So these numbers chop off, and 53.5 grams of HCl is the answer to my question, ... if I use up all of the POCl3. However, I don't know if I run out of POCl3 or if I run out of water. Now, maybe you can kind of predict in your head, thinking about the ratios and thinking about how that's going to work out, but we got to show our work. In science, we got to show where we get our answers. So I'm going to start with my other given, 75 grams of water, all the same steps. I need to get to grams of HCl, which means I need to switch over from water to HCl, and I can only switch over if I'm in moles. So I got to go from grams to moles of water. H2 is 1.01 times 2. O is 16. Added up, we get 18.02 grams per mole. And again, these numbers come from the periodic table. I need grams to cancel, so I put the 18.02 grams on the bottom, 1 mole of water on top, grams cancels. I'm at moles of water, but if I'm going to get to grams of HCl, I need to do the mole to mole switchover step. So I look at my balanced equation. I want moles of water to cancel. There are 3 moles of water in this balanced equation and 3 moles of HCl. The water goes on the bottom, so that moles of water cancels. Now I'm at moles of HCl. I can use this information, finish it the same way I did up here. So I need moles of HCl to cancel, so moles of HCl goes on the bottom. 36.46 grams of HCl is equal to it on the top. I'm at grams of HCl. That is what the problem is asking for. Ready for calculator. Multiply all the numbers on the top, divide all the numbers on the bottom. I end up with this math answer. I look at my sig figs, 3 sig figs, 4 sig figs, 4 sig figs. These don't count for sig figs because there's no error measured in those numbers. So I can keep 3. 1, 2, 3. I look at this number for rounding, which it does. So then this final answer is 152 grams of HCl. All right, now here's the part where we got to think a little bit. Back to reviewing limiting reactant. Limiting reactant is what runs out first and the reaction stops. So between the two answers, we take the smaller amount because I could never make this many grams of HCl. It wasn't possible. Why not? Because by the time I made this many grams of HCl, I ran out of 75 grams of POCl3 and the reaction stopped. So I can't make any more HCl if I don't have any POCl3, right? So this is our limiting reactant. That's just a review from the other day. So to determine the limiting reactant, you get your 2 answers of product. The smaller amount of product given is your limiting reactant. And then this is our theoretical answer for this. How many grams of HCl? All right, go ahead and do a level 2 question. Maybe you could say, explain why the answer is 53.5 grams instead of 152. That'd be a great level 2 kind of question. Otherwise, go ahead and use your cost of question guide or make up your own level 2 question. Take a little break, pause the video, come back when you're ready to go on. Okay, so now we've got our limiting reactant and we have our theoretical amount of grams of HCl that should be produced in the lab. But when we did the lab, we only made 50.2 grams of HCl. All right, so what is our percent yield? Here, finally, this is the new topic for today. Percent yield, we know it's going to be in percent, and percent always compares part and whole. What this is asking for is what did I actually make compared to what theoretically I was supposed to make. We times it by 100 to get it into percent. So for this example, here's our lab data. How do I know? Because it says in lab. And then the previous screen was our theoretical because it was given just by a hypothesis, just on paper. So actual is the lab number, 50.2. Theoretical came from that prediction we made by doing the LR problem. So 50.2 grams of HCl is the actual because that's what we made in lab. The 53.5 grams of HCl, that came from the LR problem. We times it by 100. Grams of HCl is going to cancel. Pop it in your calculator. The calculator says 93 blah, 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 right? Look at sig figs. I have 3 sig figs and 3 sig figs. Again, grams have canceled. So that's where the percent comes from. I can keep 1, 2, 3 sig figs. I look at this number for rounding, which it does not. So these math numbers go away. My science answer is 93.8%. percent yield. All right. So that's the math of how we find percent yield. But now let's talk about what it means. So actual over theoretical. So think about it. If these two numbers were the same, that would be 1 times 100, 100%. So if what we actually made was what we were supposed to make, that would be a perfect percent yield. So percent yield is telling us how accurately we performed the experiment. And the goal is 100% because that means your actual and your theoretical are the same. But if you get more than 100%, well, think about what that means. How can you actually make more than was possible? You can't get extra credit in a chemical reaction. So if you're getting more than 100%, when you measured out your actual, it wasn't pure. There must have been something else in it. Maybe there was, I mean, you could even say there was dust particles, or maybe a lot of times if you, water was still mixed in, or one of your other reactants was still in there, didn't finish reacting. So if your product isn't pure, you would get an actual number higher than what that looked possible. And so then that would get a percent yield of higher than 100%. So this would be your error you would talk about. You think about the steps of the lab and make a prediction of, oh, where could we maybe still have something mixed into our product that didn't filter properly or didn't evaporate or something got spilled in there so the product isn't pure. If you get less than 100%, so that means you have less actual than you should have, that means that you lost some of your product. So again, maybe during filtering or transferring from one beaker to an Erlenmeyer flask or stuck on a stir rod or something splashed out onto the counter. So if your actual measurement is lower than what your theoretical amount was predicted, you would get a percent yield less than 100. And then you would need to think about your procedure and predict where might you have lost some product to explain that. So again, we use percent yield as kind of an error analysis. How do we do? And if it's greater than or less than 100, both of them are errors, but for different reasons. Okay, so that introduces this idea of percent yield, kind of like thinking about how well our lab went based on LR problems and stoich problems and all that good stuff. Go ahead and do a level 3 question. I think a great one would be predict why percent yield would be useful. Predict a situation where percent yield would be useful. Because that makes you think about the context of this and why would we care about a topic such as this one. Otherwise, make up your own level 3 question and come on back when you're ready. That brings us to the end of the third day of this unit on stoichiometry. So go back and finish any Costa questions if they're not done and do your summary for today. Remember, the summary should answer your essential question. You should look back at that LR practice from a couple days ago. It's due on February 19th if you're watching this during distance learning trimester 2. Finish that practice and turn that in or get help on it. And then you could also look at some of the unit practice problems related to percent yield. So today's topics are 25 through 29 in the unit practice problems. Again, they're back in the week 9 folder if you need to find them. Check your answers. It gives you a chance to process and see if the new information makes sense. Get help as needed. And then I just also will make a plug for missing work as we're winding down our days in the trimester. If you're missing especially lab reports, those are hurting your grade. And so I don't want you to get a low grade just because you didn't do the work. So get the work turned in so I can assess you on what you actually know. All right, we'll see you at our next Zoom. Thanks for joining me today for another topic in chemistry. See you next time.